All right, and welcome back to another day of working with angles. So just to review where we've been this week, earlier this week we were talking about finding the amount of degrees in angles when we were given straight lines, right? And we know that on a straight line, there's 180 degrees. And then we were also talking about finding missing angles around a point when we know a lot of other angles, but we're maybe missing one of the angles. And that point would be at an intersection point where there's a lot of lines coming together. Well, today we're going to add on to our understanding of angles, and we're going to have to understand the term line and vertical angles. So two intersecting lines form vertical angles. And we have two lines here. We have line AB and we have line CD. And I've just traced them out for us. There would probably be more so line segments because I don't have arrows drawn on the ends of them, but we'll call them lines for the sake of this argument. So we have two lines here. We have line AB and line CD, and they're meeting at this intersection point right here. So today's lesson is going to talk to us about this amazing math angle property that's going to help us find the missing angles in these kind of line systems. So vertical angles are congruent to one another. And congruent is a geometry term that means they're equal to one another. So for example, I'm going to come into my smartboard mode and I'm going to say, well, here's my intersection point right here, okay? Now let's call this yellow arc up here. Let's say that this is 120 degrees, okay? Well, since this is line AB and this is line CD, I don't have to work my way all around and use the rule of 180 for the amount of degrees that are on a line. What I can do is immediately find this missing angle over here, okay? I can find out that this angle is also 120 degrees because they're angles that are across from one another on where two lines meet, rather. So this line AB, this line CD, they form this angle here and this angle here. Because those lines are straight, they're not changing directions. So the amount of degrees up here in the yellow arc is the same down here in this arc. So it's 120 degrees. Now, I could figure out how many degrees are in the blue arc as well. So I can come over here, and now this is when I say, wow, I can really figure out what that's going to be. I'm going to trace this out very quickly, and I'm going to do it in this, whatever color this may be. And I'm going to put that there. And on line AB, we see that these two arcs together equal that line. So that's 180 degrees, right? So coming back to my pen feature, I can say I have 180 degrees minus 120 degrees, and I'm going to have 60 degrees in this arc right here. So I did have to do a little bit of math here to figure out how many degrees were in this arc. But I don't have to do any more subtraction work to figure out what's over here. Could I figure out that, hey, this is the other side of this line, and it's 180 minus 120 gives me 60? Absolutely. But these are vertical angles, okay? So this 60-degree mark is going to be the same over here, again, because they run through that intersection point, or run around that intersection point. So over here, this is also going to be 60 degrees. Sounds a little confusing right now. Let's see if we can put this into practice on these boards. So I'm going to switch back and make this full screen for us. And I'm going to be working on my dry erase board over to the side. And I have a line system here. We don't care what the names of the points are on the line. We just care that we have three missing angles here. And before even starting out, I'm going to ask the question, can I start this problem without doing any math, understanding that this is a straight line and this is a straight line? And the answer to that is yes. I can find one of these angles right away without having to do any math. Which angle is that going to be? That's going to be angle E, because it's vertical, it's opposite the 75 over here. So they're formed by these angles right here. We see how there's that intersection point right here? So I was able to find that E is also going to be 75 degrees. So the measure of angle E is 75. Now, in order to figure out what D or F are, I have to figure out either using this 75 or this 75, which one of those I want to use. So I'm going to draw this line right here, and I'm going to say, well, if this is 75, then angle F lies on a line, so I'm going to use the rule of angles on a line. So 180 minus 75, and that will give me 105 degrees for angle F. Now, could I do the same math work for D? Absolutely, and technically I already have because it's 180 minus 75 over here. Could I change it around and do 180 minus the other 75? Yeah, I'm still going to end up with 105. But what I really can remember is that here we have vertical angles. D and F are vertical angles, so they're going to be congruent. So angle D is 105 degrees as well. And that's how I really use vertical angles to help me get through an angle system a little bit faster. Now down here, we have to find the measure of angle X. And here, I'm going to draw a little bit more detail now. And I'm going to say we have line, this is line XY, and this is line TU. Okay? So now that we have some more detail and we have line XY and line TU, we'll put the arrows there so they're not segments. So I have line XY and line TU. And I have this 140 degree angle. Can I figure out what angle X is? And I'm going to say, well, there's a vertical angle here. And that vertical angle is right here on these lines. So I know that the whole thing right here is 140 degrees. However, the vertical angle up here is being split into two angles. So we can see that there's two angles here. There's angle X, and then there's this very convenient symbol. This symbol is our right angle symbol. So that is going to be 90 degrees for us. Now, if this angle is vertical to this angle, it's congruent as well, then this entire angle up here that I'm doing in dotted lines has to be equal to 140 degrees. Well, if part of it is 90 degrees, angle X is the missing part. So what's left over? I can do 140 minus 90 and get 50 degrees. So vertical angles can help me figure out missing angles within other vertical angles. So they're a very convenient way of figuring out what I need to actually find and use. Our next example is going to be on this line system. Okay, and once again, we have a straight line here. We'll call it line AB. And over here, we have line CD. And here we have just a ray. So the ray is, it starts at a point and continues on forever in only one direction. Lines continue on in two directions. So I have a 123 degree angle right here. And that vertical angle is going to be over here. And once again, I have 123 degrees here. I have 36 degrees here and missing angle Y. So this is very similar to the previous problem we just did, where we had to figure that this entire distance right here is going to be equal to this angle. So this entire distance is 123 degrees. Well, if part of that distance is 36 degrees, I just need to figure out what this distance is. So I can figure out 123 minus 36, and then I can subtract and come up with 87 degrees. So this is 87 degrees over here, and if I want to be super mathematical, I can say the measure of angle Y equals 87 degrees. Okay, so vertical angles can save me a lot of time, and there could be less information given to us in these problems. One final example. So here we have, again, two lines, line AB and line CD. And we have to figure out some missing information here. We have to figure out angle T, and we have to figure out angle U. And in vertical angle problems, we'll play with the vertical angles, but we might also have to bring up our rule for angles on a line, which is 180 degrees. We might also have to bring up angles around a point, which is 360 degrees. So what's important here is that I can manipulate this in any way that I really need to help me out. So what I like to do is I'm going to ask myself, hey, can I cover up half of this with something that will block out a couple angles and maybe leave it easy for me to solve? And the answer is yes. I drop my index card right here. On the computer, you might use a Post-it, or you might take another index card, something to cover up exactly on the line. So I trace line CD with my index card, and I can see I have angle T and 27 degrees. So I can absolutely use this to help me out here. So I'm going to use angles on a line, and I'm going to do 180 minus 27 to find that angle T. So the measure of angle T is 153 degrees. Now that was pretty helpful. Now I have angle U over here. And again, I can ask myself, is there something I can do to make this a little bit easier for me? Well, there's two things, okay? One of those things is to, again, use that index card. And look, I can cover up on line AB. And this is a problem like we had earlier this week when we were covering angles on a line. We have two angles that we know, and we have to figure out angle U. So angle U, I'm going to write down here, this is the measure of angle T. And now the measure of angle U, this is, I need to figure out how many degrees I have so far on the line. 27 plus 46 gives me 73. How many degrees are on a straight line? Well, that's my rule of 180. 180 minus 73. And it looks like I'm going to get 107 degrees here. There's actually another way that I can check this problem and make sure that my answer works out. So what I'm going to do is take a look at vertical angles. Now I know that this here is a vertical angle to this, oops, not this one, sorry, this one here. Put my line back. So here I have a vertical angle, and we know that it's 153 degrees rather. And here I have angle U plus 46 equals that same vertical angle, 153. So if I use the vertical angle and I realize that U plus 46 is 153, well, if I take away the 46 here, I should end up with 107. So I'm going to use vertical angles to check my math work to make sure that this is correct. So starting with 153, now I'm going to take away the 46 because this entire distance here should have been 153 degrees. We know that this here is 46, so we need to confirm that when we subtract 46 from 153, I'm going to end up with 107. And 13 minus 6 gives me 7. And I get the same answer. So therefore, if my answers agree, I used two different strategies, my answer has to be correct, unless of course I made some kind of big mathematical error, but I didn't make any math errors here. So I've checked my work using a bunch of strategies. What we went over today was that it's important to look for those vertical angles, but it's also important to keep in mind the other two strategies that we went through earlier in the week. Using angles on a line can be very, very beneficial, and subtracting from 180 might be a little bit more friendly than using 360. You could also use angles around a point and play with the 360-degree idea as well. So today what you're going to do, you're going to take this learning and you're going to continue working on a Google form all on your own. As always, make sure you reach out if you have any questions.